Find the area of the region bounded by this curve and the y-axis. So we need to recall that the area of a curve bounded by the y-axis is the integral from a to b of x dy, since it's the values of y that are changing and we are integrating with respect to the y-axis. So we need to first of all make x the subject of the formula so that we can substitute into our integral formula. Now, if y is equal to square root of x minus 2, this implies that x would just be y squared plus 2, right? Substituting that, we are going to have the integral of y squared plus 2 dy, which is pretty simple. This will give us y cubed plus 2y, and we need to substitute 0 to 2. Okay, substituting 2, you have 2 cubed over 3 plus 2 times 2. But if you substitute 0, everything's going to cancel down to 0, right? Okay, working this out, you'll have 8 over 3 plus a 4, and this will give us 20 over 3 square units. The graph of y equal to x minus 1 to the power 4 minus 1 is shown. Find the area of the shaded region by evaluating the integral from negative 1 to 2 of x minus 1 to the power 4 minus 1. So, first of all, we notice here that this graph is in two sections. We have section A and section B, but we have to be careful because B is in the negative region. So we need to actually separate this graph into two parts and integrate twice. When we integrate the section B part, we need to find the absolute value of the function because it's going to give us a negative value. So in that case, this would be the integral from negative 1 to 0 of the function plus the integral of 0 to 2 of the same function. So the integral of x minus 1 to the power 4 is equal to 1/5 times x minus 1 to the power 5 minus x from negative 1 to 0 plus 1/5 x minus 1 to the power 5 minus x from 0 to 2. If we substitute each of these limits, we would get negative 1/5 minus negative 32 over 5 plus 1. That's for the first part. Now, for the second part, which is in yellow, we would get 1/5 minus 2 minus 1/5, which would give us negative 8 over 5 square units, which I said would be negative. So then we have to find the magnitude or the absolute value of this before adding them up together. So in this case, our final answer would be 26 over 5 units plus 8 over 5 units, and that gives us 34 over 5 units. Question 47. Find the area between the curve and the x-axis y equal to x squared plus 3x between negative 1 and 2. Okay, so we do the same process. We separate this from negative 1 to 0 and 0 to 2. The integral of the function x squared plus 3x would be x cubed over 3 plus 3x squared over 2. After integrating, we substitute each of the limits before adding them up. So this would be 0 minus negative 1/3 plus 3 over 2, which is negative 7 over 6 units, and that's normal if it's negative. And for the second part, we get 8/3 plus 12 over 2, which is 52 over 6 square units. Hence, the final area would be 59 over 6 square units. Question 48. The diagram shows the graphs of y equal to 2x plus 7 and y equal to 10 minus x. Find the area of the shaded region. So here we have two straight lines. We need to take the area of the top graph minus the area of the bottom graph. So we need to determine which is which. So the top graph has positive gradient, right? So if we look at the two equations given to us, y equal to 2x plus 7 is the one with the positive gradient, and the negative gradient is the one with 10 minus x. So the integral of 2x plus 7 minus the integral of 10 minus x, and it's given between the region 2 and 4. So if we integrate 2x plus 7, we're going to have 2x squared over 2 plus 7x. And if we integrate 10 minus x, we'll have 10x minus x squared over 2. So we're going a little bit faster because I've explained all of these before. So now we substitute the limits 2 to 4. And here we would have 16 plus 28 minus 4 plus 14. This is 26 square units. Now for the second part of the graph, which is the one with the negative gradient, we substitute 4 and 2 again, and we get 14 square units. Now we subtract 26 and 14, and that will give us 12 square units.